Good evening, welcome in RNQ Izino classes. Unit 3 Historical Realism. 3.1 Introduction. Some historians like R.G. Collingwood, for whom perception and history are identical, 1924 to 04, argue for a realistic view of history. They tend to take history as the exact description of what happened in the past, but there are strong reactions against this view. History necessarily involves interpretations of what, how, and why something happened. It is never a clear description of the past, as it all depends on who writes. History critics like Goldstein argue that historians can be taken to be as constituting history. 1976 in Philosophy of Science. Also, the role of history can be exaggerated, as history of science is not a real description of what happened in the past. Historical realism, the contemporary dominant school of philosophy of science, is said to be a midway position between logical positivism (LP) and historicism in viewing the role of history of science in envisaging science. The historical realists argue that both made the mistake of going to the extremes. LP absolutized science, while historicism went to the other extreme of relativism, relativizing science and rendering it almost irrational. So the historical realist, as opposed to logical positivism, say everything in science is changeable, as nothing is final and absolute. However, against historicists, they show that these changes take place in a rational and responsible manner, and therefore anything can't go in science. They understand rationality in science in a non-traditional way, and new criteria of rationality emerge from the scientific community. All these go to show the compulsory need and relevance of history of science to do philosophy of science. We discuss some of the contributions of three philosophers of science of this school: Lakatos, Laodan, and Sapir. 3.2 Imre Lakatos, 1924 to 1974, Enriching Proper and Cohen. Lakatos, born in Hungary in 1922, lived in a very disturbed times of the World War II. Through his mother and grandmother were murdered, he could escape pursuing a political career. By 1947, he became a powerful figure with the Hungarian Ministry of Education. He was nevertheless imprisoned in 1950. Later, he escaped to Vienna in 1956, thence to Cambridge, where he worked for his second doctorate under R.B. Braithwaite, attached by proper ideas. He regularly attended his lectures. Lakatos' famous work, proofs and refutations of collections of his articles in Philosophy of Mathematics, posthumously published in 1976. He challenges LP's claim of sharp distinction between the context of discovery and the context of justification. He started teaching in England. The government did not grant him citizenship, and so he remained technically stateless. In 1974, he had a sudden death of heart attack. Scientific Research Program (SRP). Science is made up of many research programs involving a series of theory science Science revolution consists in one research program setting, not necessarily rejecting the various one. There are series of theories which are related to one another, like T1, T2, T3, T4, Tn, where each being an improvement upon the preceding one. Example: research program of Copernican Copernican system in 1543. Copernicus gave us the theory of heliocentrism. Through it was rather crowd. The basic idea of having the stationary sun at the center was correct, but other aspects like Epicurus' circular orbits of the planets were not correct. Let this be caught. Then came Kepler, who removed the epicycles and replaced the circular orbits with the elliptical ones, but Kepler could not say why planets move the ellipse this way. With the elliptical ones, but Kepler could not say why planets move in ellipses. This be called COP2. This then Hooke's explained the elliptical path with centrifugal force, and this can be COP3. Newton with his mathematical maneuver made it still better, and let this be COP4. Laplace made the theory even better by explaining scientifically the Laplace theory can be COP5. Thus the Copernican system reached its betterment with the contributions of many, each one improving the previous one. Science must be assessed in terms of such SRP, not of individual theories. Proper and logical positivists hold that a theory or a law is the basic unit of inquiry in science. SRP is much more comprehensive than a theory. Example: instead of looking at individual kings like Karikalan, Raja Cholan, etc. of the Chola period of the ancient South India, we must take the whole of Chola period as one unit. Two parts of a SRP: one negative heuristic of hardcore. Every SRP has a core part giving the very identity of the program. It is the metaphysical presuppositions of the program. Individual theories may be rejected, but as long as the hard core is kept intact and the program keep going, it is the non-negatable part that can't be compromised or changed. It is forbidden to modify or reject it since it forbids any change. It is called negative heuristic. Examples for the hardcore sun-centeredness in the Copernican system, the mechanical view of the world in the Newtonian system, that is positive heuristic or protective belt. Positive heuristic is the changeable parts of the SRP that protects the hardcore from being challenged. It allows changes to keep the hardcore intact. It consists of partially articulated sets of suggestions. It specifies the directions in which the research must proceed. It directs us how to take care of the anomalies and modify the research program. It also contains metaphysical principles. Example: orbits of the planets either elliptical or circular in the Copernican system. Evaluation of SRP: it is evaluated in terms of the nature of the problem shift. It is progressive if it is able to explain all the problems of the fact of the previous program and to predict predict new fact. It is perfectly rational to pursue the new program even if any one of the conditions is made with a progressive research program with theoretically progressive a very successive theory has some excess empirical content and more predictive power than its predecessor, and it is empirically progressive if some of its excessive empirical content is corroborated. Thus, SRP seems to give a rational picture of science because at least some of the predictions must be established. A progressive research program is one which is both theoretically and empirically progressive. A problem shift is scientific if it is at least theoretically progressive, and if not, it will be pseudo scientific. Thus, he does away with the falsification criterion to demarcate science from non-science. A, a degenerating program would be not only not giving new facts but also not explaining those of the previous program, so it is not progressive both theoretically or empirically. Rejection of SRP. SRP is never rejected in haste even if it is degenerating, and it is only set aside according to LP if a theory can be verified for proper if not falsified it has to be thrown away. But Lakatos argues that we can know whether a research program is degenerating only by hindsight. For example, Newton initiated the particle theory of light as a genius. He also knew the wave theory, but he realized that the wave theory was not tenable for light. But by the circular experiment conducted by Fizeau and Foucault, the particle theory was rejected. Einstein resurrected it. Hence, it is rational to work on degenerative problems instead of rejecting it outright. Proliferations of SRP. There is no possibility of inductively confirming a theory. There are lots of problems in induction. Philosophically, through it works in actual practice, the hardcore of a research program is maybe false. We can know whether it is true or false only by intellectually confirming, but since induction has problems, no amount of testing theories of research program can guarantee the validity of theory. It is irrational to assume that any particular research truth can be guaranteed. Then it is enough to have only one research program. If not, then it is good to have many research programs, and by comparing them accept what is better. We can only talk of comparative superiority, not of absolute superiority of SRP. Lakatos, Kuhan and Proper. Lakatos aims at a sort of a synthesis of Proper and Kuhan as through grafting the revolutionary ideas Kuhan on the Properian tree. Proper gives him, so to say, the framework, and Kuhan gives him the contents. Going along with Kuhan, he saw that the basic unit of analysis in science must be much broader than a single theory. Lakatos' SRP is very similar to Kuhan's paradigm, but Lakatos demands many SRPs at a given time. Paradigm thought Kuhan gives the worldview, but for Lakatos, SRP does not give any worldview. Kuhan's normal science period has a dogmatic nature. The scientist in it can't easily challenge the paradigm and try to observe the anomalies into the existing system, but SRP rules out such dogmatism as a Lakatos combines it with the property and attitude of dropping or degenerating research under certain objectively defined conditions. Lakatos SRP does not give any worldwide Cohen's normal science period has a dogmatic nature. The scientist in it can't easily challenge the paradigm and try to observe the anomalies into the existing system, but SRP rules out such dogmatism as lactose combines it with a Propherian attitude of dropping or degenerating SRP under certain objectively defined conditions. Thus, the community in the science Cohen's game is socio-physiological when Lakatos. Hello, sir.
ये सुबह सुबह मैंने चालू किया 11 बजे कुछ चालू किया था अभी तक। यहाँ पे दोनों एसी कम से कम कितना कूलिंग होना चाहिए? क्या रिमोट ऑफ कर लो। ये रिमोट को तुम मैंने बहुत मुश्किल से देख चुका। मेरे ख्याल से पीछे से कुछ तो गड़बड़ नहीं है। लाइट मैच हुआ तो नहीं कर दिया।
कुछ काम किया था क्या इधर काम किया था कुछ
नहीं जब से तुमने लगाया इधर क्या काम करेंगे
धूल जमा होगा
तो ये इसका वजह से जमा होगा चूहा तोड़ता है ना गिरा होगा। इसका ना ये जो रिसेप्शन है इसका है किससे?
Hello, good afternoon. Sulispa. Local or northeast? No. आप कौन सी का बात कर सुलिस ना चार्ज 3,800 स्टार्टिंग प्राइस यस रूम का पिक्चर ओके आई विल आस्क माय मैनेजर एंड देन आई विल सेंड यू नहीं ना हम छुट्टी पे हैं 1978-90 further refines Q on account of theory, changing adoptions of a new paradigm to be not rational. Further, it fails to distinguish actual science from pseudo science, but lactose with the notions of progressive of degenerating problems. It tries to make the Kuhan account more rational, which would also demigrate problem shifts tries to make the Kohanian account more rational, which would also demigrate science from non-science. Hello, sir.
ठीक है भैया तो एक काम कीजिए व्हाट्सएप कर
Sir, Priya. Sir, Sarul, sir.
कैसी वाला है कौन है सियाबी जिस लड़की के है
उसने कुछ बोला नहीं, फटाक से भाग गए।
तिलक चल रहा है तिलक चल रहा है मेरे घर के पास है
ओके
Lakatos called himself a disciple of Proper in many ways. He followed Proper, for instance, like Proper. चिल्टन सन कौन है? चिल्टन सन आने वाले हैं। नेहा मैम ने मैसेज डाला है।
तो नहीं यार
Chintanson regular client 7.5
सोलह
per
का
60.
आईफोन लेगा उसमें कोई नहीं पकड़ता वो भी
बहुत कम है,
हाँ
बहुत कम है।
क्यों
या सड़े गले माल लगाओगे तो उसमें क्या कूलिंग आएगा? कुछ अच्छा ढंग का लगाओ, खर्चा करो जरा। इधर आ, इधर बताओ, मोबाइल आ, इधर। ये आता है उल्टा रहेगा। ऐसे पकड़ो। समझ गए? इधर आ जाओ। इधर आ।
Lakatos called himself
इधर
a
लगा के उठा।
disciple of Proper in many ways. He followed Proper.
समझा? हाँ, ठीक। बाल बढ़ाने से कोई ये नहीं बन जाए, लड़की नहीं बन जाता। कमांडो वाले आने नहीं लगते आजकल सारों से मिलने के लिए। हैं? ओए, कमांडो वाले आने नहीं मिलने के लिए।
कौन सा कमांडो करेगा क्या मालूम उसको जिंदगी मैंने सालों में ऐसा इतना जल्दी क्यों कमांडो बनना चाहिए
चल,
मुझे छोड़ के
पैसे वैसे दे रहे थे?
मैं क्या
हैं? इधर देख के बोल, मैं इधर देख के बोल।
अरे तुम वो लेकर आओ ना यार शाम को वो क्या बोलते हैं
क्या?
रिमोट लेकर आ जाओ ना कभी आओ तब
नहीं, अभी 3 दिन के बाद। अबे कल वैलेंटाइन डे है, लेके जाऊंगा आइटम को घूमने के लिए। तो 2 दिन
परसों आ रहे हो ना
मंडे को आऊंगा।
तभी लेके चलना रिमोट लेकर आना लेकिन हाँ अभी इसका क्या कूलिंग आएगा ना
आ रहा है, आ रहा है, कूलिंग आ रहा है।
क्या
मेरे तरफ तो नहीं आ रहा है। Lakatos called himself Lakatos called himself a disciple of Proper in many ways. He followed Proper, for instance, like Proper. He also argued for proliferations of theories and comparative superiority of theories. However, through Lakatos began as a Properian, slowly he moved on the critique Proper's view. His paper Changes in the Problem of Inductive Logic 1968 was actually a defense of proper view of inductive logic, while proper demarcations and induction 1974 was a serious critique of proper solutions of Hume problems, proper and logical positivists and unbridgeable gap between the context of justifications and the context of discovery. They all insisted that science and logic must be concerned only with the context of justifications, not with the context of discovery. Disagreeing with us, Lakatos proposes a new concept of philosophy of science which dilutes any such distinction. The unit of inquiry for Lakatos is not a theory but a SRP proper rejected a theory if it was not falsifiable, but Lakatos is not for any hasty rejections of SRP proper proper falsification was proved to be untenable as Duhem Cohen showed that any theory could survive falsifications with AD modifications. Lakatos proposes a modified falsification. A theory can be considered falsified only with an only with an alternative theory is proposed with the following features. The new theory has more empirical content than the falsified one. It is able to predicate more novel facts which were imp- improbable or even forbidden by the first theory. It solves all the problems solved by the previous.
Thank you.
Welcome, sir. Have some water.
We could anyway.
Lakatos SRP does not give any world view. Kuhan's normal science period has a dogmatic nature. The scientist in it can easily challenge a paradigm and try to observe the anomalies into the existing system, but SRP rules out such dogmatism. At Lakatos combines it with the Properian attitude of dropping a degenerating SRP under certain objectively defined conditions. Thus, the continuity in science in Cohen's scheme is socio-physiological, while in Lakatos' framework it is normative. Lakatos 1970-90 further he finds Cohen's account of theory changes adoptions of a new paradigm to be not rational. Further, it fails to distinguish actual science from pseudo science, but Lakatos with the notions of progressive of degenerating problem shift tries to make the Kuhian account more rational, which would also denigrate science from non-science. Lakatos called himself a disciple of Proper in many ways, followed Proper for instance like Proper. He also argued for proliferations of theories and comparative superiority of theories. However, through Lakatos began as a Properian. Slowly he moved on to critical Proper view. His paper changes in the ah, His paper changes in the problem of inductive logic 1968 was actually a defense of Proper's view of inductive logic. Phil Proper in Demonstration and in Inductions 1974 was a serious critic of proper solutions of Hume's problem. Proper and logical positivists insisted that science logic must be concerned only with the context of justifications, not with the context of discovery. Disagreeing with this, Lakatos proposes a new concept of philosophy of science which dilutes any such distinction. The unit of inquiry for Lakatos is not a theory but SRP. Proper rejected a theory if it was not falsifiable, but Lakatos is not for any hasty rejection of SRP. Proper falsification was proved to be untenable as Duhem Quine showed that any theory could survive falsification with HOC modifications. Lakatos proposes a modified falsification theory can be considered falsified only when an alternative theory is proposed with the following features. The new theory has more empirical content than the falsified one. It is able to predicate more mobile facts which were improbable or even forbidden by the first theory. It solves all the problems solved by the previous theory, and it has more content that is corroborated 1971-16. Therefore, unlike proper Lakatos argues that a theory can be dropped even if it's a falsified unless There is an alternative theory is available. A theory can be dropped as pointed out above only when the whole of SRP of which it is component becomes degenerative and gets rejected as a whole SRP. Remark: Lakatos succeeds to a certain extent in integrating Kuhn's ideas of science as a social enterprise with a proper normative methodology. Like Kuhn, Lakatos is convinced that science is always guided by a theoretical framework, but he makes his SRP motivate as proper makes falsifications. In the framework of SRP, a theory becomes a better theory by superseding the previous one with a move towards betterment. Lakatos carefully avoids the issue of truth and verisimilitude of proper ideas by making problem shift as the criterion. As the criterion for the demarcations of science and pseudoscience. Lakatos is not drawing a strict line between scientific and non-scientific theories, but he recommends a certain methodology by which one has to construct theoretically progressive mm, problem shifts and avoid going in for degenerating ones. BI Lakatos give due importance to historical dimensions of philosophy of science. A methodology must study both successful and not so successful episodes on history of science and look for influence is very essential to do a proper philosophy of science, because as he rightly declares, philosophy as science without history of science is empty. History of science without philosophy of science is blind. Lakatos 1971-91. SRP is better described as a theory of history of historiography rather than a methodology of such research program, for it does not give a strict rules of practice. It is not very clear as to when to when to abandon or SRP. Critics have pointed out that if a methodology had not given instructions about the choice from competing research programs, it is not really a methodology. Lakatos seems to give only a framework or theory of historical appraisal and not any scientific and practical methodology. Musgrave argues that hardcore of SRP is not historically correct and methodologically effective. For example, the scientists before 1850 did not treat Newtonian gravitation law as a part of hardcore. The elements in the hardcore are also not treat Newton gravitation's law as a. Thank you, sir. Have some water.
Pardon?
Water.
Yeah, water will be fine. Thank you.
Correct methodology effective. For example, the scientists before 1850 did not treat Newtonian gravitation law as a part of hardcore. The elements in the hardcore are also not refutable but treated as the fundamental theoretical postulates or axioms of a theory. It is a sort of a convention admits the scientists that makes them hold on to hardcore in spite of anomalies. Musgrave 1917 1110. The role of the नेहा मैम का कॉल है, नेहा थेरेपिस्ट। आप बात कर लोगे क्या सारे सर के फोन में? ये धूप axioms of theory. It is a sort of a conventions and amidst the scientist that makes them hold on to hardcore in spite of anomalies. Musaghab 1917 110. The role of the individual scientist is minimized will the significance of conventions is stressed. More further, Lakatos does not elaborate how certain hypotheses are to be chosen for hardcore category. Edwin Hung 1997 403 and the other critics point out Lakatos insist that in progressive SRP, the successive theories must have more empirical content, but this is a vague concept as an many of the cases it is not possible to ascertain this. Also he claims that the latter theory must have more explanatory power that the previous one, but he has not given a clear notions of explanation, say whether it is a contextual or casual or edificatory theories of explanation. Finally, if Lakatos distance himself from the questions of truth or nearness of to truth propose verisimilitude. Why are the scientists expected to choose and the progressive programmers, and what would be the criterion to choose one program from the other? 3.3 Deudelet's effort transcending classical empiricism and rationalism. Spare, one of the leading philosophers of science of our times, he had his doctoral studies at Harvard and worked at several prestigious institutes. His famous works include Galileo of Philosophical Study and 1974 and Reason and the Search of Knowledge Investigations in the Philosophy of Science 1984. He critiques both logical positivism and the post-positivist philosophics of science to arrive at a balanced understanding of science. He has taken it up as his life vocations to delve into the philosophical fundamentals of science. He is known for his innumerable, even complicated case studies from history of science. Has science to substantiate his position. He has taken philosophy of science as his mission about the project of the recent works. The rational dynamics of inquiry and the values of knowledge we have mentioned to me personal interview on 6th October 2006, that is residence in North Carolina, USA. I mainly do it writing the books for myself. It clears up what I am. Surface important ideas like methodology, observation, meaning, and incommensurability in science, the notions of domain and goal, success, the absence of specific doubt in science, the role of the given experiments, the need to learn, how to learn, etc. all seem to be a well connected webs through there are different modes in a fishing net. However, this action discussed only two men contributes contributions, the notions of observation and continent interactional empiricism. Observations as a concept schema. To understand the contemporary sophisticated science fair argues it is the better that one treats the important concepts like observation, meaning reality, truth, knowledge, and so on as concept schema rather than individual concept, for the meanings of these concepts are not given once and for all as an individual concept rather than developed over the years with her related aspects. A concept schema implies that it is formulated in terms of a framework that remains reasonably stable of a significant period of time to our contemporaneous areas of inquiry. Second, it is treated as part of an approach to inquiry and the interpretations of its results. Classical empiricism wrongly equates observation with the sense perceptions with the existence of sense perception. Classical empiricism is not only insufficient to understand science and its problems, but also it is largely irrelevant and even positively obstructing the process. For even if all our knowledge were shown to be ultimately based on sense perception, we would still not know or understand knowledge fully, as our sense perception covers only a limited sections in the
नहीं आपको
whole range of electromagnetic EM spectrum. The normal light, which is visible to our human eyes, is just one portion of the vast spectrum, 0.40 to 0.7 gamma rays, with extremely short wavelength, as short as billionth of wavelength of the visible light are at the one and at the other end are the radio waves with trillion time higher wavelength of the visible light. The eye therefore comes to be regarded as a particular sort of electromagnetic receptor detector capable of detecting eco- el- electromagnetic waves of the blue of the red wavelengths. There being other sorts of receptors capable of detecting other ranges of that spectrum. This generalized notion of a receptor or detector thus includes the eyes as one type. Safar 1982-505. There is no pure observation, and all observation are theory laden. Modern science does not hold evidential as perpetual because sense perception is often unreliable, seeing the health emerged as bent and incapable in the areas are of too small or too big in size, or with the objects too near or too far. Have 2000 the conditions for something to be observable information is received by appropriate receptor. That information is transmitted directly with any inference to the receptor from the entity. Safer 1988 B308. The information of transformed by appropriate devices into humanity accessible information, which is eventually perceived by a human being. Spire 1982-517. This interpretation makes observation intelligible to humans. What is observable? Unobservable is determined by a number of factors like the instruments used, the theoretical knowledge which tells you tells the nature of interactions, the theoretical possibilities of detections of particular interactions, and how the particular interaction give information about the sources. Thus, a concept of observation is not a single notion through the captured biological or a priori analysis. It is a concept schema evolving over the years, in, intertwined with the methodology and background knowledge. The scientific status of unobservable in modern science. There are certain things that can never the perceived directly, like particles in the fluid chamber, as one can observe only the track of the practice. Modern cosmology teaches that the part of the universe will not be observable by us unless it enters our horizon, and if the universe is infinite, that at any given time there will always be regions which are unobservable. Spare 2159. Practical physics and modern cosmology encounters problems and theories for which observational or experimental test appear impossible even in principle. For instance, dark matter and dark energy can be directly observed by can be known only from the effects that create. Classical empiricism might ignore such entities and theories such unscientific as they are unobservable and unstable, but science considers all these and legitimate objects of scientific study through their unobservable in principle. Of course, Sapir does not permit and bizarre entity theory to be treated as scientific. He gives guidelines to distinguish between legitimate and wild law speculations in accepting something observable in science. If the entity is logically and mathematically implied by something that is already observable or has observable consequences, if it is needed for considerations even though it is not implied by the observable parts of the theory, and if it provides answer to problems concerning the observable part of the theory with which no other solution is dealt successfully. These guidelines, of course, are to be taken in spirit, not in letters. However, despite the liability, it is by no means the case that anything goes past Sapphire 2159. A rational descendant of classical empiricism, transcending traditional rationalism and empiricism. Traditionally, two major epistemological groups, empiricism and rationalism, have tried to clarify the issues related with knowledge and knowing, which empiricism maintains that all pieces of knowledge, concepts, and beliefs are rooted in experience for their source and justification. Rationalism argues that at least some knowledge of affirm attainable by reason, independent of experience, without any interactions with the reality outside. Problems with empiricism: it fails to clearly clarify what is meant by pure observation, which does not need to interpretation, and to show how all the other non-observational beliefs are rooted in observation. It falls to realize that since experience does involve inference, as there is no pure given available, if the importance of the given in experience is stretched too far, one would land in solipsism, as one can justify believing in anything beyond one's own experience. One can't speak of past or future, which are basically international in nature, going beyond the given of here and now. Chapman 1988 B301 empiricism claims all our knowledge is based on sense experience. It is analytic, a matter of definitions, or empirical, a matter of fact. In both cases, it would be highly problematic of analytic. It can on its own principles tell us nothing about the matters of fact with which it seems to be concerned. But if it is empirical, if can't be established with absolute certainty, Spires 2001 therefore empiricism itself, like its conclusions, as an empirical doctrine, and so it can bring itself so to a stage at which it is outgrows itself. Problem with rationalism: it could not establishing substantive truths about reality totally independent of any connections with the senses. Even the compromise proposed by Kant to synthesize the empiricism and rationalism is also problematic for Kant's priori initiative from space-time category and the principles of causality have been seriously questioned by the contemporary physics. Is by 1988 separate views of knowledge-seeking process such rational descendant of classical empiricism. It is empiricism because we have to interact with the world to learn about it, and it is rational descendant as well because we have to learn what is it interact with the help of the background information. We have to learn to how to learn. It is neither an A prioristic rationalism, neurosensory empiricism, through it takes certain important aspects from both of them into considerations, namely we bring some background information to interpret the data available. However, that background information is changeable for specific reasons. It is neither relevant nor foundationalist due to the fact that the observation situation is infused with background information, and there is the given in the whole of inquiry is both of historical and rational, because even what contacts us reason to emerge of the periods of history, and finally it is far more content with logical form through logic is not excluded. Spare 1995 25-26 remarks. Spare balanced approach through Spare does not take extreme positions. His views deserve serious considerations. He evokes a lot of reactions from philosophers and philosophers of science, probably because he attempts at a balanced view between the positivists and the historicist, not just a compromise, but he seeks to transcend both by inculcating the strengths and avoids the weaknesses of each other, offering a coherent and often attractive vision of scientific inquiry. Nicholas, 1985 310. The role and the need for background information. Sapir has shown, rightly so, as how science bases itself on background information and at the same time preserves its rational character in terms of the given. Modern science has taught us that we need to learn how to learn about reality, how to think and speak about it, how to refer to what we study, and how to judge the result of our investigations. About 2000 and 2200, the demarcations between the observable and the unobservable, scientific and the non-scientific, scientific possibilities and impossibilities, scientific problems and the procedural problems, all are not something given once and for all, but rather shaped as our knowledge and understanding accumulates. Sapir, 1971-1000. Therefore, science is an enterprise that has developed over generation, building and background information. This reveals the central importance of historical dimension in science. Sapir on observation, as observation is not sense perception. Sapir argues that humans are needed only at the end of the process of observation, where it has to be interpreted. Jaffe, however, argues that an observation as such needs some human observes some sort of beliefs, and therefore what is done by the instrument, it is in fact not a measurement. No such beliefs are involved in observation. There is hardly any difference between a camera seeing, a scanner reading a document, and human observing. Since beliefs are involved in human observation, we are not merely seeing something but are saying that something is the case, and this international component is that which elevates perception. Observation 5 2173. In analyzing the notions of observation, Visargis includes consensus in the scientific community as fourth conditions. Perhaps he thinks that the notions of background information takes care of this takes care of this aspect, but I think it is also important in modern science that it needs a specific mention. This consensus is also one of the tools to overcome the experiments regress on modern science, especially with an experiment is run to decide whether an entity exists or not. The issue is a correct result of an experiment is one that occurs when the experimental apparatus is functioning properly under uses proper method, but we check proper functions of the apparatus by whether or not the experiment returns the correct result. STP
Are we there? Are we busy one? Huh?
Arul, 1 minute, just check. माया और सिया का मैं लिखी हूँ यहाँ पे, आरोही का यहाँ पे नहीं बता रहा है। In analyzing the notions observation, we suggest he includes consensus in the scientific community as forthcoming. Perhaps he thinks that the notions of background of information takes care of this aspect, but I think it is so important in modern science that it needs a specific mentions that this consensus is also one of the tools of overcome to experiments degrees in modern science, especially when an experiment is done to decide whether an entity exists or not. This issue is correct result as an experiment is one that occurs when the experimental apparatus is functioning properly and it and it uses proper method, but we check proper functions of the apparatus by whether or not the experiment returns the correct result. http www galleon library or G block P105. If the results are positive, one can conclude that entity field force in questions exists. In negative, it does not exist, but there can be methodological or mechanical, or seems to be no other way of checking if out independent of all these produces procedures. Such areas of investigations lastly rarely open the conscious in the scientific community. Spare of a speaker or knowledge with openness spare 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 invites. Thank you, sir.
1% I took now.
Sorry.
1 hour I took now.
Sorry.
1 hour I took, right?
1 hour is
It is 40 minutes.
no.
Yeah. You can check.
45 minutes or 60 minutes?
60 minutes, 60 minutes.
60 minutes done.
You
When will you go? When you go?
you can see the timing of the bill, no? Billing time.
कितने बजे गए थे चेक कर देंगे
6:30 I took.
उसमें मत चेक करो, ग्रुप में चेक करो ना, उसमें मैसेज
माया का
है ना? फोन आपके पास है?
Happy house.
दो फोन दो, चेक करो ना ग्रुप।
चेक करो माया थी ना 6:31
Already she put heater and asked me to wait. I took bath and I came back. It was only 40 minutes.
so sorry next time you get more 30 minutes
You
behind
can,
right
you can see now. I have 7:30, right? What is the time now?
Shahrukh
Sorry, sir. Just wait. Teacher invites us to learn how to learn from nature. He comes across a genuine seeker of knowledge with much openness. We must be prepared for the possibility that there are indeed more things in heaven and earth that are dream of, of in our present picture of the universe. Even the universe appeared 1987 331. 3.4 Larry Lorden Science of Problem Solving Enterprise. As Lorden, he acknowledged in his prominent work Progress and its Problems 1977. He is always happy that he was taught by and or to work with many stalwarts of philosophy of science as Hampel, Cohen, Feyerabend, Popper, Lakatos, Adolf Grunbaum, and so on. This is in where makes it clear that all these people have influenced his thinking. He attempts to take the works of Cohen and Lakatos further to have a better understanding of science and its
ए मुसरा
methodology.
खाएगा कुछ
नहीं, आज भूख नहीं है।
आज भूख नहीं है 9 बजे तक भूख
भूख
लगा
लगता तो मैं आपको
नो
कभी
बाबा,
का बोल देती थी।
नहीं जब भी तेरा भूख लग गया तभी मैं निकलू घोड़ा नहीं हूँ मैं जब भी तेरा टांग दुखा तभी मुझे सवारी कर दो
नहीं आज भूख नहीं लग रहा है, मेरे को बोली ही नहीं गोविंद भाई को।
अरे बोलेगा इसको लगा पे खिलाने खाता हमारे लिए खाता है
ये हाथ बच रहा है हम लोग
Works of Cohen Lakatos further to have better understanding of science and its methodology. In his Science and Hypothesis 1981, he traces the method of hypothesis, then Galileo and Descartes to Peirce to show the important role the hypothesis in the natural science and to study the philosophical efforts of analyze the structure of hypothetical of deductive explanation. Is another important work, Science and Values 1984, is not about ethics of science and a scientist. It is about the cognitive values involved in science. It is and its methodologies. He focused on rationality in science rather than morality in science. Through the latter is also of great importance. Empirical problems in science. All the questions about the functions of nature, why things fall to the earth, why offspring manifest the characteristics of the parents, and many such queries are empirical problems. He differentiates between problems and facts, between solving a problem and explaining a fact. Problem arise in a given context, the theoretical background, information also what and what not to expect, and this in turn decides what is normal and peculiar, what is problematic in one domain of inquiry may not be problematic in another context. A scientific theory is a solution to an empirical problem. Here one need not worry about the truth or falsity of the theory because its ability to solve a problem at a given time is that which matters, and it may even turn out the doubt would be ineffective to solve later. Science is nothing but a problem solving system. Science therefore does not aim at truth but only on problem solving ability. Science solves empirical problem roughly in terms of explaining the phenomena. Science has to explain not only the sensual phenomena but also anomalies. If an empirical problem P has been solved by the theory, then for other theories in the relevant domain which can't solve the problem P becomes an anomaly. So unless we have a theory to explain a phenomenon, it will not be considered an anomaly. According to Newton's theory, there was some discrepancy in determining the orbit of Mercury. The postulated the presence of another unknown planet to explain the discrepancy of Mercury, but unfortunately, this planet we ever discovered the discrepancy was not considered as an anomaly until Einstein's general theory of relativity explained the discrepancy in 1916. Solving an anomaly however is one secondary aim of science. In fact, anomalies are not in nature, but they reveal in the lacuna in theories. Anomalies for theories, they are symptoms of diseases, not diseases of nature, but diseases of theories. Edwin Hugh 408. Thus empirical problems can be either problems of explanation or anomalous problems. The progress of science can be assessed in terms of the problem solving effectiveness and theories laid on 1977-68. Conceptual problems. In science, conceptual problems are more significant than empirical problems. Empirical problems are related to experiments, observation, etc. But conceptual problems are richer, more than empirical problems. Conceptual problems enable science to grow. When a theory is proposed to solve some empirical problems, very often they end up cheating some conceptual problems, which can be either internal or external. Conceptual problems arise for a theory T in one of the two ways. When T exhibits certain internal inconsistencies, or when its basic categories of analysis are vague and unclear. There are internal conceptual problems. Example, Bohr's model at atomic theory can be an example for the internal conceptual problem. His model involved the picture of classical elections, yet he spoke about the radiating energy in discrete quanta, an idea given by new quantum physics much later. When T is the conflict with the another theory of doctrine T, which proponents of T believe to be rationally well founded, there is external conceptual problems laid on 1977-49. Example, when Copernicus proposed the heliocentric theory, it had external conceptual problem as it was inconsistent with the prevailing Aristotelian theory of geocentrism. Conceptual problems can also arise from differing worldviews of the scientist. Example example when Newton proposed the gravitational theory between the sun and the planets. His critics like Leibniz and Huygens were not ready to accept it because they could not understand the notions of actions at a distance, as they were engrossed with the Cartesian worldview of action through contact. Further, conceptual problems can also arise due to the difference in the methodologies. Example, problems due to Elvis inductive method of proper hypothetic deductive method. Research traditions at in order to improve hope on the notions of Kuhan's paradigm and Lakatos SRP, Loudon proposes research tradition RT, which provides science with analogy and a methodology. Like a paradigm RT specifies the kinds of fundamental entities to the used in theories, and it defines its own empirical problems. However, the difference between paradigm and RT is the replacement of one paradigm. Another is like a gestlet switch, sudden and abrupt, and also like a physiological conversion, whereas the RT changes step by step, as they have hardcore which does not easily give into changes. Similarly, unlike Cohen's paradigm, there can be more than one competing RT can exist. RT can evolve over time, and sometimes two traditions can get amalgamated. Loudon 1977-104. The efficiency and adequacy of a RT can be assessed at a given time, or can be done over a period of its lifetime. The RT with the most problem-solving efficiency is accepted. However, other traditions are not rejected immediately. They also can be taken for further pursuit because they may be able to solve it in future. Scientists may decide to pursue RT through they may not accept it, and there can be several RTs at a time. It is only reasonable to accept one research traditions at any one time. It is not unreasonably to pursue several research traditions simultaneously. Edwin Hung 412. For Kuhan, there can be only one paradigm for the wind. Insist insists that scientists work in different paradigms for science to be progressive, and for Lakatos it is better to be with the progressive SRP through it is not irrational to stay with a degenerating SRP, but Loudon, by electively distinguishing between accepted tradition and pursuing tradition, has achieved a sort of compromise between all the methodologies. Remarks to say that science aims only at solving the problems may not be right description. Scientists to expect and believe that theories give some sort of truth of or insights about the nature and structure of the world. One only for outside science may appear just to be a problem solving activity, and one will not know what scientists do not how they look at science. Problem solving may be one of the important aspects of the science, but this fails to capture the richness of what science can and does accomplish. Moreover, in this science, many problems are not yet solved, maybe never, like the origin of the universe. One may question that why solving problems science does not actually make progress through. One may get better insight by solving a problem 4 minus 3 1. What is one accomplished? Loudon does not give any criterion to show what is and what is not a satisfactory solution. Also, the problem-solving effectiveness is not a quantitative measurement. Further, solving an empirical problem is in fact to explain the problem, but that does not explain what a scientific explanation or a theory is, nor the relationship between them. Without making all these elements clear, his methodology is rather empty. Hung 1997 413. Loudon agrees that there is no theory natural in language, a theory free observation, but theory ladness does not lead to the famous problem in incommensurability. Further, he explained that assumptions to understand a problem and those to solve it are different. Different people can propose different theories to solve a problem, but the understanding of the problem may be common. For instance, about the nature of light, practical theory, Newton laws, longitudinal wave theory, Huygens and transfer wave theory, Young and Frenzel were proposed by science also had the common problem about light. These theories were comparable, but science Lardon has not analyzed what an explanation is and theory is. We can't understand across theoretical explanations and theory the problem of incommensurability is left unaddressed.